Hello class, we're about to start section 7.1, adding and subtracting polynomial expressions and functions. We have a monomial, a term that is the product of numbers and or variables which are raised to a whole number of powers. Basically that's one term. Coefficient of a term, the numerical multiplier of a monomial term. So basically it's the number that is connected to the variable. And then the degree of the term, the sum of exponents on variables, and that's per term. So we will look here. We have our monomial. We have 6x to the fifth power. This is one term. Now, what we will have to do is the coefficient is always the number that's multiplied to the variable. So the coefficient here would be 6. Now we look here for the degree of this monomial. We look at the exponent of the variable. The exponent of the variable is 5, so the degree of this monomial is 5. Now we go here to the second monomial. We have x squared y to the 4th. Now we don't see a number multiplied to the variables, but we know we always assume that 1 is multiplied to the variables, and that would be the coefficient. Now we look here at the exponents for the degree. Since this is one term, you add all of the exponents. We have 2 plus 4, so our degree would be 6. Now we go down here to this next value. We have negative 8 times n. Now, the coefficient here would be negative 8. Now, we look here at n. It does not show an exponent. Whenever you have a variable that does not show an exponent, that exponent is assumed to be 1. So the degree is 1 here. Now we come here to 5. Now this is also a monomial even though it does not have a variable. The coefficient, still the number, which would be 5. Now the degree, when you don't have a variable, your degree is 0. Okay, now we move on. We have a polynomial, the sum of monomial terms. Leading coefficient, coefficient of the highest degree term, and the degree of a polynomial, the degree of the highest degree term. Okay, let me ask you all this question. What actually separates terms? Does anyone know what separates terms?
Variable.
Okay. You said variables? Okay. This is what separates terms. Addition and subtraction are the only things that separates terms. So right here with this polynomial, we have 2 terms because they're separated by subtraction. It doesn't matter how long you have a term. If there's no addition or subtraction there, then it is one term. So if I had all of this, 4xw, I should have put y, and then z. Even though all of this is together, 4xw, y, z, this is still one term because there's no addition separated or subtraction. So now we come here. We want the list of terms. The first term is 2x to the 3rd power. The second term is a negative 5x. So we'll put a comma here. Now as you all see, this is jumping. So what I'm going to do as far as the list of terms, I'm going to write them over here off to the side. So we know 2x cubed is the first term, and then a negative 5x is the second term. Because if you notice, it would not jump over here. So you would put this under your list of terms. Now we come here to the leading coefficient. Now what we do is we look at the term that has the highest degree. This term here has a degree of 3. This term here only has a degree of 1. So the leading coefficient would be 2 because it lines up with the highest degree. Now we want the degree of the polynomial. It's the highest degree, which here would be 3. Does everyone follow that? Okay, now we come here. We have 7 minus x squared minus 6x. How many terms do we have here? 3. We have 3 terms. So if we look at these 3 terms, the terms are, we can write them off to the side here, 7, negative x squared, and then also a negative 6x. Now remember, you will write all of these terms under the list of terms in your course pack. Now we want the leading coefficient. We look at the degree of each term. This is 0. This first term is 0. The second term is 2. And the third term is 1. So we know that the second term is actually our leading coefficient. Now we know the coefficient of a minus x squared is negative 1. That's the leading coefficient. And then finally the degree is this exponent of the leading coefficient, which here would be 2.
Six.
Wait a minute, say that one more time.
Oh, never mind. Would it be a negative or no?
No, it'd be positive 2. We're talking about the exponent. The exponent is the degree.
Oh, okay.
Okay. Now we come here. We have 1, 2, 3, 4 terms. We have 4 terms here. Now, we can write, this is what I'll do, because I cannot write all of these terms off to the side. What I'll do is I'll circle them, you write them down, and put a comma in between them. So the first one here would be this 4x y squared. You have to write the square as well. And then since this is positive, you will write this down, comma. Then the next thing you will write down, and this jumped as well, you will write down this 5x cubed y. And then the next, I would just underline this. The next would be a negative 9x squared, and then the minus 2. So just to recap what you should have written here, you should have written this 4x squared at 4xy squared, 5x cubed y, and then negative 9x squared, and then negative 2. And remember, a comma separates all of them. Now, for our leading coefficient, we look here at the degree of each one of these terms. This first term, you know that this exponent of the x is 1, and 1 plus 2 is 3. So we know the degree of the first term is 3. The degree of the second term here is 4, because it's assumed to be a 1 for the exponent of y. This third one we know is 2, and the last one is 0. So we know that the second term is actually our highest degree, which we would use as leading coefficient, which would be 5. Now, we add the degree up. 3 plus 1 is 4. So that would be our degree. Now, we come down here to the next value. We have 3 terms here. Now, we have negative 9x squared, which would be our first term. We will put a comma. 4x to the third would be your second term, comma, and then negative 10. Just to recap again, negative 9x squared is your first term, you will put comma. 4x cubed is your second term, comma. And your last term would be negative 10. Now that's what will go on the list of terms. Now we go to leading coefficient. If we look here, we know our degrees are 2, 3, and 0. So we know this second term is has our leading coefficient, which is 4. Okay, now the degree we know would be 3. Okay, now we come here to the last value. We still have 3 terms here. So our 3 terms are 3p to the 4th q, then comma, 4p to the 5th, comma, negative 8p to the 6th q to the 3rd. Just to repeat it again, it would be 3p to the 4th q, comma, 4p to the 5th, comma, negative 8p to the 6th q to the 3rd. Now, we want our leading coefficient. We look at the degree of each one of these terms. This would be 5. This would be 5. And this would be 9. So we know that this would be our, this will have our leading coefficient, which would be negative 8. Now, our degree of this polynomial would be 9. The degree would be 9, because we would add these exponents. Now, we scroll down here. It says polynomials are often written in descending order. Variable exponents decrease from left to right. A polynomial of degree 1 is called linear. Now, a polynomial of degree 2 is called quadratic. And then a polynomial of degree 3 is called cubic. Now, coming down here to this next table that we have here. Now remember, these items do jump. So I'm going to try my best to write this out for you. Okay, first, it says it gives us our expressions. Now, it tells us to rewrite in descending order. Now, when we rewrite this in descending order, that means that we write the highest degree first, and then we go down to the lowest degree. Okay, so now, we have 3x minus x squared. So we know that the negative x squared will go first, and then plus 3x. So this is how we will rewrite it. Does everyone follow that? Okay, now the degree. We do the degree the same way we did in the previous table. We look here, this degree is 2, this degree is 1. We take the highest degree, which would be 2. Now we have to label this as cubic, quadratic, linear, or none. Which one do you think this is? It's quadratic. That is correct. Now I'm going to abbreviate it because it may jump. So it's quadratic, so I just put quad. Okay, now we go down here to this next value here, this next expression. Now we look here, we have 1, 2, 3, 4, we have 5 terms here. Okay, now we want to write this in descending order. Now we know negative 4x to the 5th will go first. So write that down, negative 4x to the 5th, that will go first. Yes, I can't write that because it's going to jump. So again, negative 4x to the 5th goes first. Now, the next thing you would write is minus x to the 4th. Okay, the next thing you would write is a positive 2x cubed. Or plus 2x cubed. Then next you would write plus 3x. And then finally you would write minus 6. So this is how it should read after you wrote it down. Negative 4x to the 5th minus x to the 4th plus 2x cubed plus 3x minus 6. So that is what you should have here in the rewrite in descending order. Now we want the degree. The highest degree here we have is 5. So that is the degree. Now we ask ourselves, is this cubic, quadratic, linear, or none? Which one do you think it would be? None. That's correct. The answer is none. Okay, now we come down here to this third value. Now, if we look here, writing this in descending order, we know the 10x cubed will go first, then plus 8x squared plus 6. So basically, it'll be 10x cubed plus 8x squared plus 6. Now, what do you think the degree would be here?
2. What, 3?
It'll be 3, because 3 is the highest of the terms. So now, is it cubic, quadratic, linear, or none?
Cubic.
It's cubic. And so we're done with that. Now, it says here, a polynomial with exactly one term is called a monomial. A polynomial with 2 terms is called a binomial. And a polynomial with 3 terms is called a trinomial. Okay, now what we have to do with this next chart here, we have to pick which one of these is correct with this expression.